This is the Aral Sea. At its peak, it was the fourth largest lake on Earth, stretching across more than 68,000 square kilometers of Central Asia. It had its own fishing fleets, ports, beaches, and its own weather. People had built entire civilizations along its shores. And then, within the span of a single human lifetime, almost all of it was gone. By the early 2000s, what had once been a body of water holding 1 trillion cubic meters had lost nearly 90% of its volume. The seafloor had become a desert, the ships had been swallowed by sand, and the ports sat dozens of kilometers from any water at all. But here's the thing today, something genuinely unexpected is happening. The Aral Sea is coming back. Not all of it, but part of it is returning. And the story of how that's happening and why it's only happening in one specific section is one of the most remarkable environmental stories of the last 100 years. To understand what happened to the Aral Sea, you first have to understand what it was. Tucked between the endless flat plains of what are now Kazakhstan and Uzbekistan, the Aral had no outlet to the ocean. It was what's called an endorheic basin, meaning that water flows in but has nowhere to drain out to. The only way water ever left was through evaporation, and the only way it stayed full was because two rivers kept replenishing it. From the north came the Sir Darya, and from the south came the Amu Darya, both carrying snowmelt and glacial runoff from the mountains of Central Asia. As long as those rivers ran freely, the sea maintained its balance. In some places it reached depths of around 70 meters, and for the people who lived along its shores, it must have seemed as permanent as the land itself. The cities that grew up around it were genuinely thriving places. Muynak, in what is now Uzbekistan, and Aralsk, in what is now Kazakhstan, were bustling port cities with large fishing fleets, functioning canneries, and economies built almost entirely around the water. The fish pulled from the Aral carp, bream, and a local species known as the Aral barbel were processed by the thousands of tons and shipped all the way across the Soviet Union. On clear days, you could reportedly look down into the water and see the shape of the seabed in fine detail. Tourists came to swim on the beaches. The sea even functioned as a natural temperature regulator for the entire region, moderating the brutal winters and the scorching summers. Life there wasn't easy by any stretch, but it was built around something real and enormous and seemingly permanent. But there was a detail that most people at the time either didn't know about or chose not to think about. On older maps of the region, the Aral's shoreline was sometimes drawn in very different places. Evidence suggested the sea had shrunk and partially recovered at least once before in its history, long before any human infrastructure depended on it. Whether that was understood by the people in charge of what happened next is unclear. What is clear is that it didn't stop them. In the early 1960s, Soviet central planners made a decision that must have seemed straightforward at the time. Central Asia's climate was dry, but its soil was workable, and cotton was enormously profitable. They called it white gold. The plan was to convert millions of hectares of steppe and semi-arid land into cotton fields, and to do that, they needed water on a massive scale. The solution was irrigation canals, and the rivers that fed the Aral Sea were the obvious source. The most ambitious of these was the Aralkum Canal, stretching nearly 1,000 kilometers through what is now Turkmenistan, roughly the distance from one end of France to the other. Thousands of workers dug through soil that had been dry for centuries, and the canals were built fast and cheaply. And that second part turned out to matter enormously, because many of them had no proper lining. A significant portion of every litre of water diverted from the rivers simply soaked into the sand before it reached any field at all. Some estimates put the loss at close to half of all the water that was diverted. It never made it to the crops, and it certainly never made it back to the sea. The Aral didn't disappear overnight. It shrank gradually over decades, but the rate accelerated as time went on. At first, the falling water level was probably easy to dismiss as a temporary drought or a natural fluctuation, but by the 1970s, the signs were undeniable. Fishermen who had worked the same waters their entire lives were watching their peers end up above dry land. The shoreline was retreating at a rate of hundreds of meters per year, in some areas leaving behind a crust of white salt wherever the water had been. The fish populations began to collapse both because the habitat was shrinking and because the salt concentration in the remaining water was rising rapidly. By the mid-1980s, commercial fishing on the Aral had effectively ended. The canneries that had employed thousands of people shut down. The sailors and fishing captains had nothing left to sail. Some of them literally broke up their own ships for scrap metal just to get by. Then, around 1987, the inevitable happened. The water level had dropped enough that the sea physically split in two. The northern portion went to Kazakhstan. The much larger southern portion remained in Uzbekistan, and the strip of exposed seabed between them stretched out under the sun, like something from a disaster film. What remained in both basins continued to evaporate and concentrate. The salt content in some areas climbed to levels 10 times higher than what it had been when the sea was full, far beyond what most marine life can survive. The ecosystem that had existed for thousands of years essentially ceased to function. The consequences didn't stop at the water's edge. All of that exposed seabed was loaded with decades worth of agricultural runoff, pesticides, fertilizers, industrial chemicals, all of which had drained into the sea over the years and settled into the sediment on the bottom. Once the water was gone, the wind got to that sediment. Massive dust storms carrying toxic salt and chemical residue began sweeping across the region, sometimes stretching for hundreds of kilometers. This wasn't just an environmental problem, it became a serious public health crisis. Rates of respiratory illness, cancers, and infant mortality in the surrounding communities climbed sharply. Scientists eventually found traces of salt from the Aral's former seabed in Greenland's ice sheet, thousands of kilometers away. There was also a more unusual problem hidden on what had once been an island in the middle of the sea. Vozrojdeniya Island had housed a Soviet biological weapons testing facility for decades. The water surrounding it was the main thing keeping whatever was stored there contained. As the Aral shrank, the island grew. By the early 2000s, it wasn't an island anymore. It was connected to the mainland by a land bridge. The concern was that biological material left behind from the facility's experiments might begin to migrate into the surrounding environment unchecked. The response was a joint decontamination effort between the United States and Uzbekistan in 2002, which addressed the most immediate concerns, and the area has since been under continuous monitoring. It's now part of the newly formed Aralkum Desert, but it's a stark illustration of just how far-reaching the consequences of the sea's disappearance turned out to be. Now, here's where the story takes its unexpected turn. When the sea split into its northern and southern halves, the two countries that inherited them ended up pursuing almost completely opposite strategies, and the results have been about as different as you'd expect. Kazakhstan, which received the smaller northern portion, realized fairly quickly that it had something the south didn't: geography that might actually work in its favor. The Northern Aral was much more compact, and it still had the Darya River flowing into it. In theory, if you could stop the water from the Darya from spreading across the vast, flat, dead expanse of the southern basin, the compact northern section might actually be refillable. The problem was that without any barrier between the two, every litre the Darya brought in simply drained south and evaporated. The northern basin was losing water just as fast as the river was putting it back. So in 2005, with funding from the World Bank, Kazakhstan built a dam. It was called the Kokaral Dam, and it stretched about 13 kilometers across the former strait that had connected the two halves of the sea. The logic was almost disarmingly simple: stop giving the water away and let it accumulate. Building it was not a simple task. Workers were operating in extreme conditions, dealing with sandstorms and a very real risk that the embankment would be washed out before it was even completed. Locals had actually attempted this before informally, using improvised earthen dams over the years, but the water always managed to break through eventually. This time, the dam was engineered to last and equipped with sluice gates that could release excess water if the pressure got too high, so the structure wouldn't fail under its own weight. Once it was in place, people waited to see what would happen. What happened was faster than almost anyone expected. Within 7 months of the dam's completion, the water level in the northern basin had risen by several meters. Scientists had predicted the process would take years. Instead, it took months. The shoreline began creeping back toward Aralsk, the port city that had been stranded dozens of kilometers from any water for years. Equipment had to be moved out of areas that had been dry desert just a few months earlier, because water was suddenly returning to them. As the fresh river water poured in and the salt concentration began to drop, something else started happening too. Fish, carp, pike perch and bream were reintroduced into the recovering water, and they survived. Within a few years, commercial fishing had resumed in the North Aral on a meaningful scale. Fresh fish were appearing in local markets again for the first time in a generation. People who had grown up being told the sea was gone were watching it come back. The south was a different story entirely. The southern Aral was roughly 10 times the size of the northern section, and the evaporation rate far exceeded anything the Amu Darya could realistically supply, especially given that Uzbekistan's economy still depended heavily on irrigated agriculture. Reversing the southern basin would have required essentially halting cotton production, which wasn't something the government was in a position to do. So instead of trying to fill it back up, Uzbekistan made a different kind of decision. Rather than fight the desert, they decided to try to tame it. The main strategy has been the large-scale planting of saxaul trees directly onto the exposed seabed. Saxaul is a tough, drought-resistant shrub that can survive in heavily saline soil where almost nothing else will grow. Its root system is effective at binding the toxic dust that would otherwise be picked up by the wind and carried across the region. Millions of trees have been planted across what is now called the Aralkum, which is essentially a new desert that didn't exist 60 years ago. Wild animals have begun moving into some of the denser, planted areas. Scientific research stations have replaced the old fishing ports, and archaeologists working on the former seabed have uncovered ruins of ancient settlements and structures that had been submerged for centuries, which, in a strange way, has confirmed the old stories about the sea having dried and refilled in previous eras. The disaster at least in part, has created a window into a history that was otherwise inaccessible. There was, for what it's worth, one idea floated over the years that could theoretically have changed the trajectory of the entire southern basin, and it was genuinely staggering in scale. Soviet engineers in the 1970s and 1980s seriously proposed reversing the flow of major Siberian rivers, specifically the Ob and the Irtysh, and redirecting their water southward through a canal stretching more than 2,200 kilometers into Central Asia. The calculations suggested that if enough water could be redirected, both basins of the Aral could be refilled within a few decades. Equipment was reportedly readied and trial excavations were begun on some sections, but by 1986, the project was halted. The concerns were significant and fairly obvious in hindsight. Diverting that volume of water from the Ob would change the salinity of the Arctic Ocean, alter regional climates in ways that were difficult to predict, flood enormous sections of Siberian forest, and require the sustained output of multiple nuclear power plants just to run the pumps. The project was shelved, and today all that remains of it in some areas are faint survey paths cutting through the taiga. The idea of a full restoration died with it. What we're left with, then, is two very different outcomes in two neighboring countries, both dealing with the consequences of the same original mistake. In Kazakhstan, the North Aral has become something genuinely remarkable, a recovery story that has happened faster than the science predicted and demonstrated what a relatively modest engineering intervention can accomplish when the geography is cooperative. The fishing industry is functioning again, the water is cleaner. The city of Aralsk, which had been left far behind by the retreating shoreline, is measurably closer to the water than it was 20 years ago. In Uzbekistan, the response has been more about adaptation than restoration, accepting that the sea is gone in the south and working to limit the ongoing damage rather than reverse it. The rusting hulls of old fishing vessels are still scattered across the Aralkum, half buried in salt and sand. They've become something of a landmark, something people seek out specifically because they're such a striking visual summary of what happened here. A ship in a desert, hundreds of kilometers from the nearest coastline, because an entire sea was drained away in the course of a few decades. The fact that some of those same ships now sit near the recovering northern shoreline makes the contrast even more striking. The Aral Sea's story is sometimes framed purely as a cautionary tale, and it is that. It's one of the largest human-caused environmental disasters ever recorded, and the communities that lived along its shores paid a price that those responsible never fully acknowledged. But it's also, now, something else. It's a story about what happens when people decide to try to undo what was done, even partially, even imperfectly. The northern recovery wasn't a plan to restore the Aral Sea. It was a plan to save a fraction of it. And even that fraction has turned out to be more than most people expected. If you made it this far, thank you so much for watching. If you have a story or a topic suggestion, you can find the submission form in the description below. If you appreciate this type of content, like and subscribe for even more strange and wonderful geography and engineering marvels.